So we've examined water in the air, and now we've talked about how that water in the air comes together and forms clouds. Now let's look at what comes out of those clouds. That's precipitation. What I need you to do is label a sheet in your notebook, put precipitation types across the top of the page in nice big bold letters so we can find it when we need it on the test. First of all, our first question, and there's going to be a series of questions you're going to answer as we go through this presentation. The first is, what is precipitation? It's one of those things that when I say it, you kind of know what I'm talking about, but you've never really defined it. Scientifically, precipitation is any form of water that falls from a cloud. Now, it's got to be falling from a cloud. Fog, or the cloud itself, is not precipitation. Lightning, even though it comes out of a cloud, is not precipitation because it's not water. Precipitation, by definition, is any time that we get water falling from a cloud. Now, you're going to need this diagram here for number 2, and this you should have picked up as you came in to the classroom today. And you see how we're going to arrange it in our notebook, and we're going to use this space over here beside it to describe the process of precipitation. What has to go on in order for us to get precipitation? First of all, we got to have evaporation. We've got to have water that goes into the sky. If the water doesn't go into the sky, it can't come back down again. Second, you know that water can evaporate, but yet it doesn't mean we're going to get precipitation. The water's got to condense. It's got to get cold, change back into a liquid, which forms our cloud. You can't have precipitation, remember, without a cloud. Well, you can have clouds and not have precipitation. After the cloud starts to condense and starts to grow and get bigger, we can see it. When the cloud gets too big or too full and it can't hold any more water, it starts to drop it. Water falls out of the cloud after it gets too full. That's what precipitation is. The only other thing I added into our picture is transpiration, because we know that plants help this process. We know that plants also allow water to get into the air and help this process occur. Now, it's not enough just to have the water up there in the sky. It's not just enough to have a cloud. You need to get a big enough clump of water together so that it gets so heavy that it starts to fall out of the cloud. And water does not like to stick to itself. What has to be present is something for the water to stick to, and that's what we call a condensation nuclei. Water doesn't like to condense amongst itself, but what will happen is water starts to stick to something else, and it has a lot easier time condensing if it's on something else. That's why you see water condensing on the outside of a water bottle. You don't see the water condensing straight out of thin air. It has to stick to something in order to condense, and that's called a condensation nuclei. Usually it's a piece of dust floating around in the air. So our third question, what is a condensation nuclei? It is a particle in the air that allows water to stick together. And that's what forms our raindrop, our snowflake. It is the start of where something starts to stick together so the water can bind to it so it gets heavy enough that it then falls out of the cloud. Now, that brings up the process of what we call cloud seeding. You know, sometimes you can have enough water in the air, but you're not going to get precipitation. You can theoretically drop stuff into a cloud that allows the water to stick together onto it, like that condensation nuclei, and then it gets enough water stuck to it that it falls as precipitation. They'll do this some places, especially in Texas, I've seen it, where it doesn't rain a whole lot, but there's still a fairly high humidity, but the farmers want to make it rain, especially if it hasn't rained for a while. They'll do what's called cloud seeding. That's when you put something in the air so that the water can stick to it so that it'll form a drop and precipitation can happen. Now, all precipitation, because it's way up in the sky, starts off frozen. you know it doesn't end up that way. The difference between precipitation is how do they finish, because they all start off generally as a little frozen piece of water way up high in the sky. Because it's so cold, it can't help but be frozen. There are 5 types of precipitation: rain, snow, sleet, freezing rain, and hail. We're going to look at 4 of those 5 today in this presentation. You're going to need this little strip of diagrams. We're going to glue them into the notebook like you see here, and then we're going to summarize them. We're going to describe them, what's going on in the space in our notebook beside it. First of all, let's talk about rain. Simplest type of precipitation, the one we're most familiar with, the one that we get the most often. Remember that up here it's cold, and most precipitation starts off frozen. Most raindrops are frozen pieces of water to begin with. What happens is they fall down and they get low enough that they get into air that's warm enough that that little frozen piece of ice melts, and we wind up with liquid water hitting the ground. That's how rain is formed. Rain is formed when the water, the frozen water, melts on its way to the ground and hits the ground as a liquid. So let's summarize that. We got frozen water that falls into warmer air, melts, and hits the ground as a liquid. Let's take a look at sleet. You can see and hear from this presentation, this is water hitting the ground, but it's not a liquid anymore. It's solid. It's little solid ice pellets. It's like frozen raindrops that are hitting the ground. And that's actually what sleet is. The question is, how does sleet form? How do we get this as opposed to rain? Well, here's how sleet forms. Remember, everything starts off frozen up here. We're frozen water. We're ice up here. And it falls into warmer air. So it melts and turns into a liquid. But this is a case where we've got 2 air masses, and they're kind of butting heads up against one another. And we got some warm air, and we got some cold air. So it melts and turns into a liquid, but then it falls into some colder air, and it freezes again. So we've got basically a raindrop that freezes, and that's what sleet is. Sleet is when frozen water falls into warm air, it melts, becomes a raindrop. Then it falls into cold air and freezes again before hitting the ground. These are frozen raindrops, that's what sleet is. You can actually see it here. Here's an up-close picture of some sleet that I took. You can see they're all, pretty small. They're little tiny little pieces of water. They're little raindrops that actually froze before hitting the ground.
So here's a situation where we have snow falling. And what must be true in order for this to happen is that the water, when it gets to the ground, can stay frozen, which means it must still be cold enough all the way to the ground for water to stay in the frozen state. This is not typically what happens in Georgia. Typically, it's going to be too warm as the water gets near to the ground, and it melts and it will turn into rain before it hits the surface. So once again, this is snow, which only happens when it is cold enough for the water to stay frozen all the way to the ground.
So let's diagram that. With snow, we've got cold air up here, we've got cold air all the way to the ground, so that my water never has a chance to melt, and it will hit the ground frozen. So cold air all the way to the ground, so the water hits the ground frozen. That's snow, and you know that it's frozen water. You can actually see this, a good example in this picture. You can kind of see right about there. That must be the point. It must be about 32 degrees Fahrenheit along that line, because up here it's cold enough for snow. Well, you notice down here there is no snow. It doesn't mean there's no precipitation down there. It just means below that point it was too warm, and the frozen water, as it fell below that line, melted, hit the ground as rain. Now, freezing rain, it's a little bit different situation. Freezing rain is when we have, once again, we got our cold air, we got our cold frozen water, and it falls into the warm air, and it melts. And really close to the ground, we've got a small layer, usually a very thin layer, of really cold air. So my raindrop, as it falls into this cold air, it doesn't have enough time to freeze before it hits the ground. It hits the ground as a liquid. But because the air on the ground is so cold, my liquid water that's now on the ground freezes solid. It is literally rain that freezes after it hits the ground. So here's the description of what's going on. Frozen water melts and hits the ground as a liquid. But we got cold air near the ground, and it makes the water freeze after hitting the ground. This is what freezing rain looks like. This is not covered in snow. This wasn't sleet. Sleet would hit your car and just bounce off. It would hit a tree limb and just bounce off. Freezing rain, though, think about everything that gets wet when you have a rainstorm. Well, everything that gets wet then freezes, and you can actually see it here. The trees get wet, but the water now freezes on the tree before falling off and hitting the ground. So the next drop of rain that comes down freezes, and you can get big layers of ice that cover anything that's outside in freezing rain. You can see it here on the car. This is an example of freezing rain. It's rain, but it freezes after it hits the ground. So we've got two types of rain. We've got showers and we've got drizzle. Showers are, rain showers are big, heavy drops of water. Those are the ones that really make you get wet when you're out there in it. Drizzle is smaller, lighter drops of water. Now let's talk about snow. Why don't we get snow in Georgia? Well, it has to do, once again, with these air masses. So where does our water come from in our air? It comes from this guy. This guy comes to us and brings us plenty of water. We can get precipitation. We get lots of precipitation, but we don't get it as snow. Well, remember that this air is hot, so the water in the air is pretty warm. So when we get the moisture to make snow, it's too warm. Well, can we get cold? Well, sure. When this guy comes to town, he can bring us some nice cold air. The problem is, when that guy comes to town and gives us cold air all the way down to the ground, he's dry. You can see that in this picture over here. This is a continental polar air mass that has come to Georgia, and you can see there's no clouds. It's cold because you can see that water is frozen, but it didn't give us snow because there was no water in the air. Take a look at this. This is a snowstorm, I think in 2019. A decent little snow. But look at the sky after the snow. And this was actually literally right after the snowstorm ended, same day. You'll notice the sky is clear of clouds. And I want you to think about times you've seen snow here in Georgia. Generally, right after it snows, we get sunny. And that's because we need that cold air coming in from Canada to get us snow. But right after the snowstorm, it tends to be clear skies because we end up with dry air. So something has to happen just right for us to get snow. So to summarize, why don't we usually get snow in Georgia? Because when we get the water to make snow, it's warm. And when we get the cold air, it's dry. And we'll examine some cases of what has to happen just right in order for us to even get snow. We get it about once a year, but stuff's got to happen just the right way.
So here we've had some snow. meaning it was cold enough for the frozen precipitation out of the sky to reach the ground in its frozen state. It's about 33 degrees out here, so right about that freezing point, just a little bit above it. But let's talk about how and why snow can be dangerous for us here in Georgia. The trick is when it hits our roads. Our roads are black, they're asphalt, and they tend to soak up sunlight. It was 70 degrees just a few days ago, so these roads soaked up a lot of sunlight and they became warm. Well, they trap heat, and so when the snow hits the asphalt, you can see it's liquid because the road is cold enough it made that snow melt. So this is not a dangerous situation. You can drive on this kind of snow. It's basically water, and you can drive on water. It's no different than driving on the rain. Where snow becomes dangerous in Georgia is what happens next. If more snow continues to fall and the temperature goes down and we drop to less than 32 degrees, especially for an extended period of time, all of this liquid snow here, all this watery snow on the surface is going to freeze and then turn into ice. And our road here will be like a solid sheet of ice. It's what we call black ice, where you get a thin layer of frozen water over the asphalt, and sometimes you can't even see it and you don't realize it's so icy. Well, today the temperatures are actually on the rise. The temperature is going to be about 44 degrees in a few hours. So all of this snow, all of this liquid snow here that's melting is going to continue to melt. And then the water's just going to run off like it normally would with rain. So this is not a dangerous event for us here in Georgia. When you get black ice is when we get snow. It starts to melt on the roads, and then the temperature drops to make it freezing sheet of ice over the asphalt.
So, what is black ice and how does it form? Because this is why we miss school. This is why we cancel school. It's not the snow itself that's a problem, it's the black ice. Well, the first step is snow falls onto the warm roads and it melts, which means we have water on our roads. And you can see that in this picture. You can see the snow is staying on the grass. But over here on the road, this road was sitting on the sunlight, it's warm, and every snowflake that hits that road is just turning to water. What happens next? The temperature drops, especially below 32, and all of this water that is on the road now freezes, and it makes a layer of ice, and it's transparent. You can't even see it because it just looks like a regular black road. You can't tell the difference if it's wet or if it's ice, and that makes it very dangerous. So this is how black ice forms. Now, why is it so dangerous? Because you can't see it. The road just looks like a normal road. Maybe it looks a little wet, which wet is okay. You also can't get rid of it. It's so slick you can't drive on it, you lose traction, and there's nothing you can do to get rid of it. You can't plow it, you can't get it out of the way, you just have to wait for it to melt. Which this is why we tend to close schools, is we're worried about people driving around, or we're worried about the school buses driving around and hitting patches of black ice. If it happens on a hill going into a neighborhood, sometimes you can't get in and out of the neighborhood, the road is too slick, and it makes it very, very dangerous. Now, why are snow events in Georgia such a big deal? I mean, we hear about this all the time. And this picture over here on the right is from our Snowmageddon in 2014 or 2015. I don't remember which one. This was a really bad event, and we get a lot of teasing in the national media about all those people down in Georgia, they don't know how to drive in the snow. But our snow down here is actually a little bit different. We have some different problems than what they have in, say, New York, where it snows all the time. One of the problems we get is we don't have any snowplows. We don't have the equipment here to deal with large amounts of snow. There's my little graphic there. Atlanta, population 4.7 million, snowplows 10. You do the math. Yeah, we don't have the capacity to go out and plow the roads like they do up north. And why would we? After the Snowmageddon, people were saying, oh, we need to buy more snowplows. Well, to use what? Once every generation? That's a lot of money to spend on something that we're not going to use very often. Now, One thing they do up north is they put salt on the roads. They have trucks that come around and spread salt on the roads. And what that does is it makes the snow melt, and it keeps the water from freezing, because salt water doesn't freeze at the same temperature. It doesn't freeze at 32. So this picture over here, the temperature was like 19 degrees or 20 degrees. It was in Rochester, New York in the wintertime one year. And yet there was still liquid water. And that's because they had spread salt on the snow, and it became salt water, which doesn't freeze until the temperature gets really, really low. Same thing here. This road, they had spread salt on that road to keep anything from freezing on top of it. We don't have that capacity to do that here in Atlanta. Even if it gets too cold, where you don't want to make the water melt, what you can do is you can spread some rock or some gravel or some sand on top of the snow. And actually, you can drive on snow. But if you put this rock and snow and sand, your tires get a little bit better traction. And they'll do that up north. They have a truck and it comes around and it just spreads the rock and the sand and stuff on top of the snow, and it makes it where the roads aren't that slick. Do we do that here in Georgia? No, we do not. We do not have the equipment or the capacity to do that. So why are snow events such a big deal here in Georgia? First thing, we tend to get black ice, which is not as much a problem up north, because up north they'll spread salt on the roads and keep the liquid water from freezing on the roads. Plus, up there, it doesn't melt in the first place. They wind up with snow on the roads, and you can drive on snow. You can't drive on ice. We don't have plows. It's not worth the money to buy snow plows for the limited amount of snow that we ever get. We just let it snow, wait a couple days for it to melt, and we get back to normal. We also don't have any salt and sand trucks. We can't go around and spread salt and sand like they can up north. Now, we have a couple trucks that do that in Atlanta, and they'll do the best they can with the biggest, busiest of roads, but they're not going around and salting the roads in your neighborhood. We don't have enough trucks to be able to do that. So we tend to get black ice. We don't have the plows to move the snow, and we don't have any way to spread salt and sand on the roads. Now, freezing rain. Freezing rain's a really bad, nasty dude. Let's talk about how we get this. We actually get this a little more consistently than places, say, up north. What happens if we get our nice, warm, wet air, and it's coming up from the Gulf of Mexico, and it hits some cold air coming down from Canada just right, and the cold air slides just underneath my warm air. So I'm getting all my rain, and it falls right into cold, cold air from Canada, right near the ground. And it hits the ground as rain and then freezes. That's what causes freezing rain. Up here, not as much a problem, because they don't have the warm part of this. They're always going to get snow. Here in the South, we have freezing rain and ice problems. And here's the problem. This is what freezing rain does. It coats our trees, makes the trees heavy. Well, sometimes the trees can't stand all the weight of that ice, and the tree limbs fall down like that. So why is that a big deal? Well, we got a lot of trees around here. And if a tree gets too heavy, gets too much ice on it, it can fall into your house. This is one of the neighbors just around the corner from me. It's an ice storm. We had freezing rain, tree got too heavy, and it fell over. That's bad news. The bigger problem with freezing rain is that those trees tend to fall on power lines, and they take out the power lines. They cut the power, which means your heater in your house won't work. And that's a problem, because This is a cold weather event. It's a little bit different than in the summertime when you have a lightning strike. And a lightning strike takes out one transformer, and maybe there's one neighborhood without their power. When you have an ice storm, this happens to trees all over the place. It's not like a lightning storm. There's a pretty small chance that a lightning storm takes out a transformer, and you know where the lightning happened. It's pretty small area. This happens all over the place when you have an ice storm. So you end up with lots of wires down. Well, you got to come out there and you got to cut down the tree and you got to rehang the wires. But remember, the road is like an ice skating rink. So it's challenging to get outside and do the work and fix the power lines when they're like this. So one of the biggest dangers for ice storms and freezing rain is down power lines. And it's not just trees. Sometimes the ice can be so heavy it'll actually make the power poles fall over, which same problem. The wires snap, you lose electricity. There is actually a rating scale that predicts what kind of damage you're going to expect. Meteorologists look at this and they throw this out there to help people get ready. A level 1 is not too bad. We're going to get some slick roads. It's only going to last a couple of hours. Be careful driving. Stay home if you can. A level 2, we're getting 12 to 24 hours of people having no electricity. And okay, you can handle that for that period of time. For a level 3, you're going to have outages lasting 1 to 5 days. Now think about that. You go without electricity for 5 days, you're not able to cook, not able to run your heater, certainly then can't go to school. That's a big event. Number 4, a level 4, and this is starting to get kind of rare, 5 to 10 days. That's widespread, like whole cities are just without power and they stay without power for an extended period of time. I don't recall ever hearing about a catastrophic storm. That's where you get outages that could last for weeks and people basically have to leave their house because there's no electricity in the whole area. So once again, why is freezing rain so dangerous? First of all, you can't drive because everything's one big sheet of ice. You're basically stuck in place. The second big reason is about power lines. Power lines snap and people lose power for extended period of time, which when it's cold, you need that power. You need it for the electricity to run your heaters. So that's the end of the presentation. Come see me for a done stamp on your notes and be ready for the notes check that will be forthcoming.